website in a comma separated value format, so I already have the customer's name, the address, and the auction paddle number, their auction number. So I thought it should be a way to maybe coordinate all this. So I thought, well, I'm gonna make just this prototype here, something I can measure the box with, so it saves a few steps. I don't have it integrated yet with the actual rate quoting software for UPS or the Postal Service yet. That's down the road. But what I'm using here is, my project is a microcontroller called the Parallax Propeller. It actually has 8 32-bit microprocessors all in one package. They're kind of in a round robin type format here. This is just sort of somewhat of a schematic that shows how it works. It runs at about 80 megahertz, and so it continuously goes around the loop and shares some of the RAM memory. It's somewhat of a limited chip compared to a lot of like the ARM chips and other stuff that you hear about that are on like a Raspberry Pi and other things like that. But it's very powerful in its own way because if you're familiar with some microcontroller programming, like a Raspberry Pi, in order to control like peripherals, like say these ultrasonic sensors or serial printers, that sort of thing, you have to use what's called interrupts in order to stage everything through and put something on the stack and then take it back off and go back and look for it. Whereas here, I've got 8 cores that I can have each doing their own thing, which is what I do. So I have one core that's doing nothing but going in a round robin here with all 5 sensors and gathering that data. I have another core that's the serial communication to the keyboard, and one that does the serial communication to the printer, and one that does the serial communication to the scale. So, and then I also have another serial connection then too. So, if I did plug a Raspberry Pi or a PC into it, I could actually download this information from it. So I'm able to do those in software, which just makes it a whole lot simpler, from my point of view anyway, to program this sort of thing. So anyway, I have 5 sensors on here. They're called parallax ping sensors. They're ultrasonic. You send it a pulse, and then it when you send it the pulse, it starts the measurement and sends a ultrasonic beam down, then it measures the reflection, and then it sends a pulse back to the microcontroller, and the length or the width of the pulse is directly proportional to the time that it took for the sense to go down and come back. So you divide it by 2 because you got the out and back. And that's in microseconds, and it converts directly to like centimeters and such. So so I use that for that, and I have a serial LCD display connecting here then too, and then like I say a keyboard. Let's see, I'll show you a little bit of the code itself. This is what's called spin language. This is the native language for the Parallax Propeller itself. So it might look similar to, I think some people say it looks similar to C, the way it's done. So at the beginning, you have your constants. You define the clock mode here. It uses what's called a prescaler, so you have a 5 megahertz crystal on there, then you multiply it times 16, and that gives you the 80 megahertz clock speed. And then I have a few other defines here, or I have 32 input-output pins that I can use on this chip. And pin 30, 31, and 30, because it starts at 0, so 31 and 30, the last 2 of those are the ones that are used to actually program the chip, but they can be used outside of that as well. So I typically leave those for unused unless I run out of pins. So here I define all my different pins that I have things connected to the displays, up to port 0, the top ping, the left ping, right ping, so on. And the scale transmit, scale receive, printer transmit, and I define the baud rates. I also have a single push button that I put on the circuit board then too that allows it to print. And here I define my variables, my various variables. My programming is probably not the most efficient or most correct, but it works. So like I say, there's a huge forum and a big community around this, so if you have questions, and they have what's called an OBEX, O-B-E-X, where there's a lot of code that's already written for different things, different objects is what's called object code. So you can go in and copy, paste it, you know, whatever you need to do. So here's where I define those different objects. So I have an object called full duplex serial. You can see that I've used it 3 times here already. And if I compile it, you can see that in my printer object here, I don't know if you can see that on the screen there or not.
Yeah, you just move this. Move
Printer object here, I also use full duplex serial. So, and full duplex serial each uses 1 cog, so you can see how versatile this chip is in being able to program all this sort of thing. So here in my main program, though, I start up the various objects here. I define the pins and the baud rates and so on for the terminal, the scale, the LCD, and the printer, and the keyboard. And then here is actually the main repeat loop that runs all the time here. Then, so I'm looking for a character coming from the terminal. So if I had the terminal program hooked up to it here, it's looking for a specific letter. In this case, either an R or a P or a T or an L, and I can control it. I use case statements for that, and then I have different methods within this loop here. Then. So first thing it does is read the scale. So if you look down here in these public methods, down here there's one that's probably says read scale. I can find it. Right there. And by the way, these are local variables. The variables up at the top are global variables. So on the scale here, I'm flushing the serial buffer, and then I'm sending it the command W. That's what that scale requires to get a reading. And then I have up to 50 milliseconds here to wait for a response. And then if I get this character 02, then that means I've got a successful read, and I just go ahead and parse out the different commands that come from it. If I don't get what I'm looking for, then I have it so that the weight variable here stores this message called scale with an exclamation point. So that way it shows on the LCD display if the scale's not hooked up, or if the scale's, you know, erratic, if it's not settled down yet, then it gives you that display so that you know that it's not ready to go. Let's see here. So it goes through that, like I see the other methods here, display the weight. And then, as I was mentioning to somebody earlier here, these ultrasonic sensors, they cannot be all triggered at the same time because they will interfere with one another, so you have to wait for them to settle down. So here I have a 5 millisecond pause in between each one. And when you come up here and take a look, you can see there's a little green LED on each one as each one's firing in sequence there. And down in here, I look for my keyboard key. I'm looking for a specific number, so it ignores everything else. It's defined as a paddle number. That's what they call it in the auction. Each customer has a paddle number. Oh, what else? So the idea, like I say, is to set the item on the scale itself. It automatically reads the dimension. Shows up on the display here. Shows the weight and the dimension. Then if I had an auction sheet, and this was something I just freshly packed, maybe the paddle number is 500, so I type in 500. Shows up on the paddle here. If there's multiple boxes within that particular auction, I could define the box number, but since there isn't, there's just one. So I'll move on to the next. My next selection here is I have options of the different types of postal mailboxes. They have small flat rate box, medium flat rate box, medium mail, first class, that sort of thing. So I have those options here. Since that's just a standard box, I bypass that. Then I have an option here of putting that person's name in. And when I'm done, it prints out a label here and shows the paddle number, the person's name, gives the dimensions and the weight. So I can stick that on the box then. And then later on, after I go out and get my rate quote, I can go back in all these boxes that I have. I can find this particular box because I got this label on it here.
Cool.
So that's pretty much it in a nutshell. This all just came, like I say, out of a dream, trying to figure out how to simplify things. That's kind of what I like to do. I'm kind of a pretensioneer at best, and I look at common things, you know, in ordinary life, and how can I automate something
Sure.
or make it different, you know, and to make things easier and simpler. So that's kind of what I do. So this project came out of that.
How long did this take, Don, to create from start to finish roughly?
To be honest with you, I've been working on this whole project for pretty close to a year.
Okay.
As far as this year, once the idea came, you know, probably within a month, you know, I had to decide, okay, what do I want for a framework? I thought, oh, PVC pipe is pretty simple, you know, you can just cut and make it, you can scale it what size you want, you just add on to it if you need to make it bigger. I sent away and had these 3D printed, these little mounts for these sensors here. And then finding, I try to find off the shelf stuff if I can, so finding these long three pin cables was kind of a challenge. And then I shopped around for a printer, a label printer that allows me to communicate serially with it. It also has USB and Wi-Fi and stuff, but I'm not using that portion of
Right.
it. I was more interested in being able to develop with it, and this one provided that feature there. So, and this is just a FedEx scale here, just, you know, any sort of scale that has serial interface would work.
And so these were 3D printed here? These were here?
Yeah, these
pieces here? Okay.
I used a service on the internet, I don't remember what it was called, but I found somebody had the file already for these things.
Sure.
So I just sent them that file, and it's one of those things that it's a flat rate. There's like a conglomerate of people that, you know, that have 3D printers, and within a couple days you got your part. You know?
There you go.
So
Questions for Don?
they
You guys have
weren't
questions?
real cheap, but they were cheaper than buying a 3D printer and
Sure.
and the long learning curve of
Right.
setting it up and stuff.
Right.
Yes.
In regards, I'm not really familiar with the auction and you know going to that business.
The auction is called proxy bid, okay, and the auctioneer is an old time auctioneer that I work for. They've been in business like 50 years, and so every Friday at 11 o'clock they have a live auction in a big old room in this warehouse, but it's also live on the proxy bid website, and you know there's thousands of auctions, you know, around the world that use that. So you're competing online. It's like eBay, but it's a live bid. So you get audio and you get pictures of what they're bidding on. So you can bid on, and you're bidding against local people then too at the same time. It's called proxy bid.
Okay. And it's the boxes. It has to be that dimension, right? To be
No, you'd be surprised what people buy. I mean, I get stuff that you can barely find a box for. You know, it's just big, and it's amazing that when they're buying that stuff, you know, they live in California. They don't realize, you know, they spent $5 for this big thing. It's going to cost them $60 to get it there. You know, and that happens a lot. You know, because shipping's not cheap.
Well, is your question, can it fit different dimension of boxes?
yeah.
Yeah.
Does it, when it you know you said about the lasers and you know how everything is measured. How would it?
Right now, I'm just set up for this size right here
Okay.
on my everyday.
And by the way, that box was in the back of the room when he came in. I just grabbed it for him to use.
Oh wow. Okay.
So he could technically use the pizza box if he wanted to,
Yeah,
or,
pizza box would work.
yeah, so we could actually do that. Did
And
you guys empty one out now?
part of my firmware in here then too, if the weight is 13 ounces or less, then it shows in ounces on here instead of pounds. So that way, if I want to ship something first class, it allows me to do that, and I have the first class weight then.
Okay,
Otherwise, above 13 ounces, then it always rounds up to the next higher pound.
and that might not be high enough too, Don. I just noticed that box might not hit the sensors.
You'd be surprised. 3 inches.
Yeah.
It is. It doesn't quite.
3
catch.
inches width 9. It did get the one little width. Height 2, width 8, depth 12.
Yeah. So it's.
Pretty good. That worked pretty good, yeah. That's it.